Hi, this is Master Microservices with End-to-End Encryption. My name is Jenn Gile. I'm a product marketer with NGINX, where I focus on our microservices and Kubernetes solutions. And for this session, I'm joined by Aidan Carson. Aidan, give us a quick intro.
Hi, Jen. Hi, everyone. My name is Aidan Carson, and I'm a software engineer on the NGINX Service Mesh project. Happy to be here.
Thank you. All right, if you've been following along with the NGINX app modernization journey throughout the demo day, at this stage, you're running Kubernetes in production, and your app is complex enough to get value from a service mesh for securing traffic at every point in your architecture. In our scenario, our digital-only bank has gotten to the point where they're ready to master microservices. They have a big, complex production Kubernetes environment running, but they're also, of course, facing challenges. There are a lot of concerns about securing traffic between services inside Kubernetes, which is very typical when people reach this level of development. And so what's the solution? This organization has decided to mandate end-to-end encryption with mutual TLS. And as part of that solution, they're going to be using a service mesh for east-west traffic management. And so we're going to take a look at where NGINX fits in. For those of you who are newer to service mesh technology or for Kubernetes traffic management, I'll give a quick, very simple overview of how traffic works in Kubernetes. Now, this first layer, when it comes in, the ingress layer, that's coming in at an L7 layer. It's highly securable. However, when traffic passes through the ingress controller to the service mesh and from the service to the pods, at that level, it's only layer 3 and 4. And this can be okay if you have a simple app and you don't have a requirement for end-to-end encryption. But it's not going to be okay if you have services communicating with each other inside the cluster, and some of those services have sensitive information such as usernames or passwords. That's where Service Mesh is going to come into play, enabling you to add that L7 oversight management at the service-to-service level. Now, taking a look at the end-to-end traffic management with NGINX and where the Service Mesh fits in there, first, your traffic is hitting NGINX App Protect, where it's blocking denial of service and HTTP attacks. Immediately after, the north-south traffic flows through NGINX Ingress Controller. And then third, it's going to get managed by NGINX Service Mesh for that east-west traffic. To see how this works in action, we're going to sit through a great demo by Aidan for the rest of this session. Aidan, walk us through what you're going to be showing.
Sure. Yeah. Thanks, Jen, for that introduction. So today, what we're going to be demoing is end-to-end encryption. So what does that mean? It means north-south, and it means east-west. We're going to be looking at ingress encryption with NGINX Ingress Controller. We're going to be looking at east-west authorization, which kind of builds on encryption, as well as egress, trying to incorporate like a legacy application.
All right, let's jump into it.
Awesome. All right, everyone, let's jump in. Before we actually demo the functionality, I wanted to give a brief overview of what we actually currently have running. So we have the NGINX Service Mesh and NGINX Ingress Controller deployed. We can see that in the NGINX Mesh namespace and the NGINX Ingress namespace. So we have within NGINX Service Mesh some metrics and tracing components, Grafana, Jaeger, Prometheus. We also have the control plane components, NAT server, NGINX Mesh API, NGINX metrics. And then what I want to drill a little bit deeper on is the Spire component, Spire agent and Spire server. So let's actually look a little bit at the architecture here. So we have the observability plane, which I mentioned, the control plane, and then data plane and infrastructure, which is anything that we're running on Kubernetes, and it could be in a managed environment all the way down to bare metal. So what I wanted to drill down into is this Spire server, Spire agent, and then workload communication. So this talk is called end-to-end encryption, but that's really only one piece of overall application security. You also need to have authentication and authorization. So encryption is going to kind of secure communication between components on the wire. If someone hops in the middle, you don't want them, snooping, sensitive data or something like that. So that's encryption. And then authentication is going to be the identity. When you're talking between two components, you want to ensure that who you're talking to is who you say it is. both of those are going to be handled by Spire. Spire implements the SPIFFE spec, which is an open standard for application security. It assumes zero trust, so that means that it assumes that every other workload in your mesh is compromised, and it does this through distributing SVIDs, or SPIFFE verifiable identity documents, to each workload to orchestrate that authentication, that encryption. And then we're going to talk about the next layer up, authorization, a little bit further into the demo. But with that baseline, let's get our application up and running. So we're actually going to be applying the book info application. You're probably familiar with this. It's used a lot to demo microservices capabilities, and we're going to be using it to demo here as well. And so typically I could port forward and show you around on the product page, but right now actually we're running in mTLS strict mode. And so this is what's recommended for production environments in order to restrict communication to only workloads in the mesh and workloads that you specify by having a sidecar injected or routing to an egress service or something like that. And so what we need to do in order to show this product page is set up an ingress. So this is going to be how I or anyone else is going to access your cluster. What we're going to do is we're going to use a ingress route. So we can see book info ingress. This is a custom resource defined by NGINX Ingress Controller in order to get traffic into your cluster. It uses, well, first we need to handle that encryption piece. So we're going to use this TLS block right here. We're going to reference a secret, which I'll show in a little bit for the host bookinfo.example.com. And then the rule is we're going to, for the host bookinfo.example.com, route / to product page 9080. Fairly straightforward. So let me actually apply that. Bookinfo ingress.yaml. Great. So before we actually look at the product page, we need to just take a look at the book info secret. And this is actually in this large text a little bit unwieldy. So we can see the secret, the name, and then just the TLS cert and TLS key. So this is going to provide the encryption piece. We're going to reference this in order to encrypt traffic coming into NGINX Ingress Controller. So let's go ahead, I'll clear it and apply book info secret. Great, so now that that's applied, we should be able to actually open up a new window and go to bookinfo.example.com. So we can see that it worked. We are using an insecure connection here. So we're still using HTTPS, but we're using a self-signed certificate in a production deployment. You would sign this just so that you can have a secure connection. So we are going to route using a normal user to the actual bulk of the product page functionality. And as you can see, there's the book info details. We have the reviews service, as well as this rating service. And this rating service has 3 different displays, 2 with stars and then 1 without. And actually, in order to show each of these is a different component, and in order to show that, I just wanted to use the Jaeger UI. So we deploy Jaeger by default, which we saw before, and we can actually use it to visualize the request traffic. So here we can see, if we pull it out, that there are these 3 versions of reviews, 2 of which are referencing those stars and then 1 without. So we have a general kind of request flow here. All right, great. So that is, in its essence, Ingress. You are completely set up and you can start routing from the public internet. The next thing that I want to show is a virtual server. So let me go ahead and delete this book info. Oops. I just missed a dash here. Book info ingress. We're going to delete that, and then we're going to take a look at book info vs. So this virtual server, this is another custom resource that NGINX Ingress Controller defines. The bones are pretty much exactly the same. What we're going to do instead well, we're going to be able to define a little bit more advanced functionality, but we're going to introduce this concept of an upstream. So if you're familiar with NGINX, you're probably familiar with upstreams. What we're going to do here is define a named upstream, product page 9080, and we are going to route traffic / to this upstream. So pretty much exactly the same as before, but now we have this advanced configuration. We can actually look at the request method, this variable, to look for whether it's a GET request. And if it's not, we're going to return this 405 method not allowed. So if we go ahead and apply that to vs.yaml, we should be able to continue to refresh and see the same functionality is still working. Awesome. Great. And now that we've sent a couple requests, we can actually look at the top command and see that we have, we can even drill down, deploy page v1. I'm just going to full screen it here. So we can see incoming success and outgoing success. And then we can see the specific PXX latencies to each separate component here if we drill down into product page v1. And so great. So that is, in its essence, ingress. We've encrypted incoming traffic, and even we've just through deploying NGINX Service Mesh, we've gotten encryption and authentication essentially for free. So those are taken care of. What we don't have is authorization. So this authorization piece, I want to talk a little bit about that. I'll hop back to this architecture slide. This is implemented via the Service Mesh interface, the SMI spec. So this is it's an interface that is implemented by a variety of different service meshes, and it's designed to be service mesh agnostic, meaning you don't have custom functionality tied to a specific service mesh that prevents you from transferring, say, from Istio to NSM, NGINX Service Mesh. And so it's nice, and the features that it allows for is things like traffic metrics. That's what allowed us to do the top just now, and traffic splitting, which is splitting traffic to different services. We also have, which is what I want to focus on, traffic specs and traffic access control. So specs and access control work in tandem to be able to define this authorization piece of, explicitly defining who can talk to who. We have encryption, which is, securing the data itself, authentication, making sure who you're talking to is who, you want to be talking to. But then we need to define whether we actually want to be talking to that entity. So let's just switch over to traffic access. And here we're going to, first of all, drill down into these different YAMLs for defining access control. So I'll full screen here and look at, say, details first. So we can see specs and access from the previous screen. And so, like I said, they work in tandem. The specs defines the traffic that you want to identify and match against. And then we have the path regex, which is the path that the detail service is going to be, wanting to accept. And then we have the access control, which is going to actually reference this HTTP route group, and then it's going to apply a destination and a source. This is going to be what allows that traffic to get through. And if we see, just as an example, actually I can stay here. We can do kubectl get pod product page -o YAML, and then I'm just showing the service account for that product page. So we're using this book info product page service account as the source, and that's going that's how we're going to define who can talk to who. So we can see if we look at the product page as well. Apologies, full screening again. This time we're not matching on a specific path regex, but still looking for get. And the structure itself is much the same. And then we're sending to the port 9080. We're allowing that traffic. And it's the same for ratings.yaml. So let's go ahead and apply these resources. So now that we've applied them, nothing is explicitly changed in our view up here. But let's actually introduce an external component. So in this scenario, let's say that this is something that you want in your NGINX Service Mesh, but it isn't tied to the core functionality of book info, your main core app. This really has no reason to be able to talk to your book info application. And so what we're actually going to do is let's test that. Let's say exec IT actually curl s product page 9080. And we can see that we're getting a 403 forbidden. So typically you would be able to just access product page as normal, and that presents itself a security risk, because if someone gains access to bash, there's no reason that you wouldn't want to, that it would need to access product page. And you can actually see here as well, we need to verify that the book info itself is working as normal, and we can see that it is. So great, so now we have access control defined. We have put in the authorization piece to application security. So we've kind of covered all of the bits of the security. So the last little bit that I want to talk about is egress. So say in this example, let's apply this. We have a target service. So this target service is something legacy, something we're not quite ready to incorporate into the management of NGINX Service Mesh, but we still want to communicate with it. So what we're going to do, let's say actually that this bash service is what's going to be responsible for communicating with this target. So first of all, let's just go ahead and try and communicate with it. I'll just exec that pod, and then let's see, curl. Let's just check out the target.yaml real quick. And then we can see the service, target service, and namespace legacy. Perfect. Okay, so let us do a kubectl exec, into our bash pod, curl-s target service.legacy. So what's happening here? We're getting a 503. What's happening is because we're running an mTLS strict mode, we are looking for a service that is under the management of NGINX Service Mesh, and we are unable to find it, so we are presenting a 503 to the workload, in this case bash. In order to begin this this communication, we need to do one thing. In order to do that, we actually need to go back to our traffic access, our bash.yaml. Let's go ahead and vim it. And we need to uncomment this annotation. So this annotation is default egress allowed. So what this does is it allows all traffic that can't find a match in the NGINX Service Mesh to get sent to the NGINX Ingress Controller for processing. That'll allow it to then be sent through egress to this legacy component. So let's go ahead and apply that, and we'll apply -f traffic access bash.yaml. So what we're going to see is we're going to see a new bash pod get spun up, and as soon as it's running, we're going to see the old bash begin to terminate. So now that we have that, let's try this again. We're going to do the new bash pod, and we're going to see the exact same command. In this case, we're getting a 404. So 404 is different from 503. It's progress, but it's not quite what we want. We're trying to get this target service. So what's happening? So we are getting sent to NGINX Ingress Controller, but there's no route to be able to handle traffic to the target service just yet. And so what we're going to do in order to do that is this last piece, this legacy route. So it's the same ingress resource as we defined before. It's essentially the same bones. We're still routing to target service on a different host, but we're adding this annotation, nsm.nginx.com/internal route gets true. So there's a flag in NGINX Ingress Controller, and I can look at it right now. kubectl describe -nginx ingress. And what this does is it allows for internal routes. And we can see all the other arg Spire agent address is what allows it to communicate with NGINX Ingress Controller. What this does is it allows for routes to from the NGINX Service Mesh to a external component, in this case, a legacy service. So if we apply it, legacy route, then we are going to create this internal route so that we can route from the batch container to the NGINX Ingress Controller and then to our legacy, this legacy component. So let's try this final command once again. And we can see that we get the correct target response. So that is essentially everything. We have worked through Ingress encryption in order to secure incoming traffic. Then we talked about how Spire works on the encryption as well as the authentication piece. And then we talked about authorization. We talked about the SMI spec in order to do access control, make sure who you're talking to is allowed, to mitigate vulnerabilities when a particular component gets compromised. And then finally, we showed how you might be able to integrate a legacy service that you still want to communicate with, but is not quite ready for management under NGINX Service Mesh. So thank you all. I hope that was informative.
All right, thank you, Aidan. That was great.
Awesome. Thanks, everyone. I hope you enjoyed, and I hope you learned something. Head to NGINX docs to learn more.
For sure. And if you're interested in microservices and Kubernetes, we have a lot more to share with you throughout NGINX Sprint. Tomorrow, we have 3 sessions to check out. 2 are training sessions, one on Kubernetes Ingress 101, and the other diving deep into how you can figure out if you're ready for a service mesh or when you're going to be ready. So that's, are you service mesh ready for that session? And then we have a hands-on workshop with our NGINX experts on NGINX Ingress Controller for Kubernetes, featuring some visualization activities. So hope to see you tomorrow. Have a good one.
Thanks, everyone.